Video we're going to look at some more variation of parameters. So in this video I'll go through a bunch of examples. I think I have one, two, three. I have 3 examples, which is plenty. Okay, so let's just dive right in. So this first question says, use the method of variation of parameters to find a particular solution of the given differential equation. Then check your answer by using the method of undetermined coefficients. So we're going to use both methods for this because we should get the same solution. As you see, we have 2e to the t here, so that could also work for undetermined coefficients, right? That's one of our cases for guessing. But you can also use variation of parameters for it, right? So that's what it wants us to do first, so let's do that. So let me rewrite this down. So we have y double prime minus 5y prime plus 6y is equal to 2e to the t. Okay. Let's solve. Let's remember we plug in, we substitute. I'll write it all out. Propose y equals e to the rt, and y double prime is, right, we substitute, we end up with the e to the rt's will cancel. Right? Oh, wait. I did forget one little thing I should have mentioned. So step 1. Solve the homogeneous equation where our g of t is equal to 0, right? This is our g of t. Okay. So that's where the 0 comes from. Anyways, now we solve for r. I think that factors nicely. Let me think. R minus 3, r minus 2. Right? So then r is equal to 3 and r is equal to 2. So in that case, our y sub h, so then our y sub h would be c1 e to the 3t plus c2 e to the 2t, right? And now from here, we can propose y sub p, where our g sub t is 2e to the t, right? So let me think. Y sub p, remember, we're going to take what we have for y sub h, and we're going to shove a u. We're going to replace the c's with u's. So this will become, if we take our y1 and y2 and we multiply them by u1 and u2, right? So we have u1 times y1, which is e to the 3t. Here, I should write this out, where we know that y1 is, right? Just in case you wondered like where my thought process is. So that's u1 e to the 3t plus u2 e to the 2t. Now, for variation of parameters, we're going to take the first derivative. We do the same thing for undetermined coefficients, right? Take the first, second derivative and then plug them back in. Excuse me. So yp prime would be 3 e to the 3. Let me do this first. Let me do the non-prime terms first. Yeah, so I'll just start with this one. 3 e to the 3t times u1. I don't know why I wrote it like that. Just keep it like that. And then we have plus 2 u2 e to the 2t plus, and then I'll do the primes now. So we have u1 prime e to the 3t plus same thing, u2 prime e to the 2t. Okay, so now this we will separate and set it equal to 0. So I'm just gonna take it like this, and I'm gonna box it off like this. Right? If you're confused with what I did here, go back to the last video. We have to take out the prime terms, set them equal to 0, and this is one of our equations that we are going to use in our system of equations. So now let's find, so now we're going to take what we have right here. This is our y sub p prime now. And we are going to find y sub p double prime. We don't have to worry about grouping primes for this one. So 9u1 e to the 3t plus 3u1 prime e to the 3t plus 4 u2 e to the 2t plus 2u2 prime e to the 2t. Sorry, my handwriting is kind of bad. But now that we have, let me just make sure that's right. Yep, 3, 9, 4, 2. Yep, we're good. Okay, so now that we have these, we're gonna go back and substitute into the original equation, or I should say ordinary differential equation. Second order ordinary differential equation. Y double prime. Okay, I can just do this. I'm just going to copy this and paste it down here. So we have y double prime minus 5y prime. So that's minus 5 times 3, which is 15, u1 e to the 3t plus 10 u2 e to the 2t. And then we have 6 plus 6y, so plus 6u1 e to the 3t plus, I think that's 12. Yeah, because 6 times 2 is 12. u2 e to the 2t. And then we set it equal to 2e to the t. Okay, so now all of this is the left side. So we can cancel some things out here. Let's see what combines. This will combine. And these will combine. So now let's see. So 9 plus 6 is 15 minus 15. Guess what? These cancel. 4 plus 10 is 14. Oh, that one doesn't cancel though. Let me just make sure. I thought the U2 should cancel. Do I have a sign error? Maybe I have a sign error somewhere. Is that supposed to be minus 5? Oh, yep, I do have a sign error. Where am I? Right here. I have a sign error, but that still doesn't cancel out, so I must have made another mistake. Let me check my work here. Yeah, those should cancel. 3, 9, 2, 4, negative 15, negative 10, 6, 6. Plus 6y. Oh, I see what I forgot. I was looking at the wrong thing. Oh, I was looking at the wrong thing. This is supposed to be, I was looking down here at the yp prime. It's supposed to be up here. So that's 6u2 e to the 2t. Now those cancel. So you gotta be careful with these because it's really easy to make a simple algebra mistake. That wasn't even an algebra mistake. That was just me not paying attention. But anyways, these also cancel. So we are left with u2 prime e to the 2t is equal to 2 e to the t. And we also have another, remember we have this equation from before. We have, let me just copy it. And we have this one from before. So now we have two equations making a system of equations. Excuse me. So if you remember the last video, I used Kramer's rule, right? I'm gonna do it again because you can also try substitution. You can try elimination, which is basically like reducing a matrix. If you know how to reduce a matrix, you can try that as well. But I am going to use Kramer's rule because my textbook uses it, and I actually kind of enjoy using Kramer's rule. It's really useful, it's really useful to get used to, especially in engineering, because when you get like later on, especially I remember in like statics, you have a lot of systems of equations sometimes, right? So I found it really useful to use Kramer's rule because it made solving the systems so much faster. But anyways, let me use Kramer's rule. So let me try, it's been a while since I did my last video, so I have to try and remember how it goes now. So we're going to solve for u1 prime and u2 prime. So u1 prime, let's see if I remember how to do this. I actually, when I first learned how to do these problems, I didn't use Kramer's rule. I did substitution. So I don't have anything to check myself on for this, but I'm going to try it. But I much prefer to do Kramer's rule now. So we have 3e to the 3t. Oh, I'm sorry. We just write down the coefficient matrix on the denominator, right? Okay, yeah, that's right. I remember that. 2e to the 2t, and then we have e to the 3t, and then e to the 2t. So we do the coefficient matrix on the bottom. And that's the same thing for u2, I believe. I'll do that down here. Let me just copy that. Okay, so u1 prime. Remember, we're going to take, oh yes, I remember now. We take the coefficient matrix and we're just going to replace the first column with what's on the right side of our equation. So we're just going to replace this first column here with 2e to the t and 0. Second column is going to stay the same. And for the second one, we're going to replace the second column. And if we had any more, like u3, u4, we would continue to do the same thing. We just replace the third, fourth, fifth columns, whatever. So for u2 prime, we would have, this stays the same, so 3 e to the 3t, e to the 3t, and then the second column will become 2e to the t and 0. Now we just take the determinants. So this will become, so let's do the denominators first. Remember, we're going to multiply these two together. So then we have 3e. You add those, yeah, 3e to the 5t. And then minus this. You subtract the multiplication of those. So that's minus 2e to the 5t. That becomes e to the 5t, right? Well, I sure hope that's going to be correct, because I'm looking at my solution here. I do have the correct u1 and u2 primes, but like I said, I didn't use Kramer's rule. But let me see now. So now we're going to look at the numerators. Hopefully this works out nicely. I think it should. So then this would be, multiply these two together. This would be 0, so then we don't have to worry about that one. But if we do this one, we'll have 2 e to the 3. Yep, we're good. and this is 2e to the 3t. So then u1 prime is 2e to the negative 2t, right? So here's my u1 prime. Now I need u2 prime. This is 0. This would be 2e to the 4t, yeah. So then this would be 2e to the negative t. So then u2 prime is 2e to the negative t. So that's my u1 prime and u2 prime. Now, I need to integrate. So this would be step 4. And step 4 would be to integrate for u1 and u2. So then we're going to integrate right? So we're going to integrate u1 prime. So then this becomes u1 is equal to excuse me, negative divided by negative 2. So negative e to the negative 2t. Take the integral of u2 prime. That'll become negative 2e to the negative t. So not too bad, right? And then we just plug in and then we go back to our yp. So let's look up here. Right here, u1 e to the 3t. So plus u2 times, I think it was e to the 2t. Yes. So then from there, let me see if that's correct. Yes. We can simplify that then, right? So then our y sub p would be, that's negative e to the t plus or minus 2 e to the t. So then y sub p is equal to wait, something's not right. U2 should be positive too. I have a sign error. Why do I have a sign error? Oh, this should be negative? How's that negative? Oh my god. I did my determinant wrong. You're supposed to subtract that part, right? It's this minus the multiplication of those two. So if you saw that mistake, that's good, right? I was simply testing you. Okay, so then this would be positive. Then this would be plus, yeah. So then, okay, yeah, then thank God I had this right though. So then yp is e to the t. So this is all the problem asked for. Now, if it did ask for the general solution, I'll do that really quick. Here, I should set step 5. Plug in. Okay. And then step 6, I guess, could be... Now, these steps might be a little different than my last video, because I did that last video like over a week ago. I was busy, but not sure if I follow these steps, but you know, it's the same process. The general solution then would be y sub p plus y sub h. I like to actually do y sub h first. Doesn't really matter. It doesn't matter. Which would then be c1 e to the 3t. Remember, this was the y sub h we got all the way back in the beginning. And then we just add y sub p, right? And this is just y is equal to. Now, this is the correct solution, the general solution, and that's our correct particular solution. This is what the problem asked for. But now it asks to check our solution by using the method of undetermined coefficients. So let's do our check. So y sub p is equal to what when g of t, let me just write this, the undetermined, I think I spelled that right, undetermined coefficients, when g sub t was, what is it, 2e to the t, I think? 2e to the t. So now, for undetermined coefficients, remember the y sub h would be the same, right? That's the same process for everything in second order. You always solve the homogeneous equation first. But now we get to this point, we have to propose our y sub p. So now we're going to propose y sub p with the guessing, well, with the educated guessing. If you remember from my guessing video, I went over every case, right? So if we're doing undetermined coefficients for this, 2e to the 2t, remember, a 2 represents, or a number that would represent a letter. So then we're going to have a. And then e to the t just follows it. So it's literally just going to be a e to the t. Very simple one, right? Very simple. And now you can already see just how much easier undetermined coefficients is for this problem. Whenever you have something simple like 2e to the t, always just use undetermined coefficients. You'll be done in like 2 minutes because you don't have to go through all those things. You don't have to do the system of equations. You know, all you have to do is do this, and then you just have one term, right? You just have one term. So this is a lot easier. So then you take the first derivative and the second derivative. They're all just ae to the t, right? Yeah. So then we plug those in. Remember it was, I forget, y double prime minus 5y prime. I think it was plus 6y. So plus 6 a e to the t is equal to, it was 2e to the t, right? So we plugged them in, and then we set equal the like term. So this, and this will be set equal. So a minus 5 plus 6a is equal to 2. 7a minus 5 is equal to 2. Here, let me add another page. I don't really need it, but I should do it just to make it look nicer. This would be 7a. Oops, that does not look like a 7a. Is equal to 2 plus 5, 7. So then a is equal to 1. So then guess what? We plug back in for a. Y sub p is e to the t. And guess what? Our answers match. And you could see just how much faster undetermined coefficients was. But it's not always going to be the case, right? Because if we look maybe at the next problem, let's see. Yeah, like the next problem, you can't use undetermined coefficients for one of these. Let's look at number 5. So don't worry about number 4. You could try it if you want to, but let me get my solution. So looking at my work, this is a longer one. Whenever you have like a secant on the right side, you know it's going to be a longer one that deals with trig. It's just the way it is. But let's get started. So remember, first things first. I'm going to kind of glance over this first step because you shouldn't be very good at this by now. But remember, for the first step, we solve the I'll start by rewriting it, so. Right? Also, you can ignore this sentence. We don't need that. Okay, so this one asks for the general solution. So first things first, solve the homogeneous. We'll be left with, remember, propose y equals e to the rt, take the first, second derivative, plug them in, cancel out to e to the rt's, and you're left with, solve the homogeneous. This would be complex, right? So then r is equal to the square root negative 9 plus minus 0 plus minus 3i. Yep, so then remember we go up here. Remember complex, we're going to use Euler's formula, but I also showed you a shortcut to get around Euler's formula. So I'm going to use that shortcut. So this is C1 e to the 0 t times either sine or cosine. I'll use, what did I use over here? I did sine first. So sine of 3t plus C2 e to the 0t, which is just 1 by the way. So I'll just get rid of those. Plus C2 cosine of 3t. Right, if you're confused with this, go back to my complex roots video and watch that. Now we propose our y sub p. This is our y sub h, right? So now we're going to propose our y sub p, which would be u1 sine 3t plus u2 cosine 3t. Yeah. So, now we take the first, second derivative. So I'm gonna need some space here. Let me come down here. Yp prime would be 3 u1 cosine of 3t plus minus 3 u2 sine of 3t plus u1 prime. I'm grouping the prime terms together, plus u2 prime sub cosine of 3t. So I grouped those together because we're going to take that and set it equal to 0. Take it out, right? So then yp, this is our yp. Sorry, yp prime. So now double prime would be 9 u1 negative 9 u1 sine of 3t minus 9 u2. I didn't have to do it like this. I don't know why I'm grouping the primes. You don't have to for y double prime. Just the way my brain went with it. Plus, minus 3 u2 prime sine of 3t. Let me just make sure that's right. Negative 9. Beautiful. 3 u1 prime minus 3 u2 prime. Perfect. Okay. Now we plug in this monstrosity into our yp prime. Into our yp. I'm sorry, into our original equation. I don't know what I'm talking about there. So double prime first. This whole thing, and then we have plus 9y. Oh, that's good. We don't have any primes. So plus 9 u1. And I already see something that cancels out, right? Plus, and I see another thing that cancels out. Right? These cancel out, and these cancel out. So, and this is equal to, forgot this, 9 secant squared, oh geez, secant squared, 3t, yeah. Secant squared, no, that sucks. All right. Let's continue. This one is a little difficult. I can already see it's gonna be a little difficult with the trig. So we can then write our system. I wish undetermined coefficients worked for secant. I think this would be a lot easier. And then what was our other one? Oh, I have it right there. U1 prime sine of 3t plus U2 prime. Right, this is where we took out from the YP prime. So now we have our two equations. So we have our system. Yeah, I'll use Cramer's rule. What did I use over here? Substitution. Oh, see, the substitution was really ugly. Oh my god, yeah, that substitution was like half a page. My substitution was half a page for this one in my original work. I'm gonna do it with Cramer's rule, because I think I can save like half a page of work by the looks of it. Oh wow. That's why it looks so ugly. I did substitution. Let's do Cramer's rule. You could try substitution, and you can check it with my Cramer's rule. Actually, here, if you want to do substitution, here, give me 1 minute. I'm going to take a picture of what I did, and I'll paste it into here so you can see it. Alright, so I took the liberty of taking a picture of that. This is the substitution. It started here. All of this is the substitution, right? So if you want to do it that way, you can check your work with this. But I'm going to do it. I know it's a little messy. I was doing it quick on paper. But I'm going to do Cramer's rule. So U1 prime and then U2 prime. The denominator would be 3 cosine 3t. I might need more space. Negative 3 sine of 3t. Sine 3t. Cosine 3t. Okay, let me just copy that. Those are U's, and that is a 2, by the way. I gotta try and write neater. Okay. Cramer's rule. I need more space though. Okay. Phew. The numerators. Let's see. For U1, we replace the first column with 9 secant squared of 3t. This is very annoying to write out, but it's still going to be faster than substitution, that's for sure. And then that other one's 0. And then this row stays the same. Okay. This one, the second one's going to get replaced. And the first one stays the same. Yep. Okay, so now let's do these. So the denominator I'll do first. We're going to have 3 cosine squared. So I can already see we're going to have a trig identity here. Very nice trig identity. Then we're going to have plus, because the negatives will cancel. Plus 3 sine squared. See how this is a very nice identity here? So then that denominator is just 3, because this plus that is 1. Take the 3's out. If I kind of glanced over that, but this is an identity. You should know this from trig or calc. You definitely have used it in calc. So this is just 1, so then you're just left with 3. That's all. So now the numerator, and the denominator for this one's the same. The numerator for this one would be 9 secant squared of 3t. And we're going to have to find a way to simplify that. The other term's just 0. So we're going to have to find a way to simplify that, I think. But for this one, let's see. The numerator is -9 secant squared 3t times sine of 3t. Well, secant, let me think. Secant is 1 over cosine. Right? So I can see how to simplify this first one. So if secant is 1 over cosine, I think it is. Let me just check that. Actually, where's my u1 prime? That's all the way down here. Secant squared cosine 3t. Oh, I just kept it like that? Why would I do that? Why would I do that? Oh, okay, I see. Well, yeah, you could do that. I mean, that's the same thing. Okay, you know what? I'll leave it like that. I will leave it like that. It doesn't matter. Because we still have to integrate it, remember? So it doesn't matter if you leave them like this, actually. So I'm just gonna go ahead and then leave them like this. So then u1 prime would be that's what I have, right? That's what I have up here when I did substitution. So then u2 prime is -3 secant squared of 3t sine of 3t. Oops. All right. Let me just make sure that's correct. That's what I have. Yep. So now we can integrate these. So yeah, I mean, you could simplify them right here, right now. But you really can't see the light until you do the integration. So I'll just go ahead and do that first. So u1, integrate u1 prime, integral 3. So now, if you're integrating this, I need another page. If we're integrating this, we're going to have to... Well, actually, no, you can simplify this one nicely. So this is u1 prime, u1 is equal to, take out the 3, the integral of this 1 over cosine, 1 over cosine is secant, right? So then cosine is 1 over secant. Okay, so knowing that, this would become just secant of 3t, right? See how that happened? So now u1 would just be the integral of secant is, what is that? I have it memorized. I had all these memorized. I think it's the natural log of secant x plus tangent x. So then that would be 3 natural log secant of 3t plus tangent of 3t. Now, if you're interested in how I got to that, look up the integral of secant. There's a long proof for it where you can just memorize it like I did. Is that right though? Yep, that's right. Oh yeah, plus C1. I always forget my C's. I did that for the last one too. I forgot the C's on the last one, didn't I? Oh no, where is it? I mean, that's okay. I got the right answer. But yeah, if you noticed, I forgot my C's. Wait, does that mean my general solution's wrong? I should have an extra C there, right? Or does it matter? Wait a minute. Actually, upon going back, it appears that I haven't included C1s at all, even in the last video. So I guess something happens where they just become, like, you just assume it's like 1 or something. I assume that happens quite a bit in these problems. I guess that's what happens, but I guess we ignore the C's. Anyways, is this U1? Yes. So now U2. We have -3. Maybe I should have split this into more than one video. I mean, that's okay. I'll include the timestamps. So now, secant is what? 1 over cosine. Okay, then we're gonna have to do u sub for this. Okay, so let me write this out for you so you can see what I mean. So u2 is equal to -3 integral. I'm gonna rewrite this as 1 over cosine squared of 3t times sine of 3t. So then you can, okay, actually, yeah, let me get right to u sub. Now let me not use u sub. Let me use, I already used t's, I already used u's, so let's do w sub or something. So then w, if we set w equal to cosine of 3t, then dw would be -3 sine 3t. So then this will cancel with that. And we're left with that. Oh, and guess what also cancels? These. So now that's it. Oh, this ain't too bad. So then u2 is -1 over u, right? E to the -2. Yeah. So then we plug back in. I'm sorry. This is supposed to be a w. We use w sub. -1 over cosine of 3t. All right. So we have our u2. We can rewrite that as negative secant of 3t, right? Yeah, and then we just do our y sub p, and we're almost done. So now our y sub p u1 sine 3t, so that's sine of 3t times all of our u1. Where is it? 3. Oh, that's ugly. Natural log secant of 3t plus tangent of 3t. Ew. plus, I guess that'd be, well, that, yeah, because we come minus, and then it was u2 cosine 3t. And guess what? These cancel with each other, right? Because this is, right? And those cancel. Or let me do that in a different color. And those cancel. So then let's do our y sub h then. So our y sub, our y, so our y sub h plus y sub p. I wonder if you can simplify that first one. I don't know. I don't think so. You know? Oh, yeah, you can. You can. I think you can. So if we go back up, our y sub h was c1 sine, c2 cosine. So that's the first half of our general solution. Second half, y sub p. Can I simplify this? Oh, actually, no. I don't think I can. You know, maybe there's a way. Maybe there's a way. But I didn't do it in my homework. And I don't want to make a mistake now. So I'm just gonna rewrite that. Actually, I'll pull that 3 out. Natural log secant 3t plus tangent. Oh man, that looks awful. And then we have another term, minus 1, right, from that. So that's our general solution. Beautiful, isn't it? See, Kramer's rule saved us a lot of work, in my opinion.